Alright, in this video we're going to learn to add vectors in one dimension. And the method that we use in order to add vectors is called the tail to tip method. And I'll show you that here in a second, and it'll continue through when we do more complicated things in multiple dimensions. Alright, so let's just first talk about a vector. Remember that a vector has both a magnitude and a direction. So in this case we're talking about one dimension. So let's say I walk from left to right a distance of, I don't know, 20 meters. Right? So notice how I draw this as an arrow. All vectors and their components should always be drawn as arrows. If you do not, I will mark it wrong on the test. Right? So let's say I walk from here to here and I go 20 meters. Now, if I were to then walk a distance of 10 meters in the same direction, let me just go ahead and draw that vector. So this is 10 meters. You can see that I have placed the tip of the, or I placed the first vector, and then I put the tail of the second vector at the tip of the previous vector. This is the tail to tip method, where essentially we put all of the vectors in order, pointing in a direction, and then the resultant vector is actually the sum of those vectors. So it would be this from the tail of the first to the tip of the last, or from where I began to where I ended up. So this would be my resultant vector. And it'd be really easy to see that just because these vectors are pointing in the same direction, that the magnitude of that vector would be directly to the right 30 meters. Okay? Now, if I wanted to reorient those vectors and change the direction, I could also put them opposite of one another. So let's say I walk to the right 20 meters, and then instead of walking to the right, I walk to the left 10 meters. And it's, pretty obvious that your displacement is going to be, 10 meters. But let's use our tail to tip method to actually draw our resultant vector, right? So I drew the first vector, and then I put the tail of the second vector at the tip of the last, and then the final vector goes, or the resultant vector goes from where I started to where I ended up, or from the tail of the first vector to the tip of the last vector. That would be my vector resultant. And in this case, if I were to take the sum of these two vectors, I'd actually make this quantity negative because it's going backwards. And so 20 minus 10 or plus negative 10 would give me a resultant vector of 10 meters. Right? So this is pretty simple in one dimension, and we'll get a little bit more complicated where we actually are going to look at vectors that are in multiple dimensions, and that's in the next video.